In this video, we are going to calculate the integral of sine of x over x from x minus infinity to plus infinity without using complex integration. The technique we are going to present in this short video can be applied to many other integrals. In order to do the integration, we introduce the function I of alpha equals to the integral from minus infinity to plus infinity of sine of alpha x over x with respect to x. We can see that the function I of alpha doesn't depend on x. If we take the derivative of I of alpha with respect to alpha, we have that the total derivative can be moved inside the integral as the partial derivative of sine of alpha x over x, which is equal to cos of alpha x. Hence, we obtain that the derivative of I alpha with respect to alpha is equal to the integral of cos of alpha x with respect to x from x equals minus infinity to plus infinity. In order to calculate the integral of cos of alpha x with respect to x, we write cos of alpha x as 1 over 2 times e2 I alpha x plus e2 minus I alpha x. Integral from minus infinity to plus infinity with respect to x of cos of alpha x can be written as 1/2 the sum of the integral of e2 I alpha x from x minus infinity to plus infinity plus the integral from minus infinity to plus infinity of e2 minus I alpha x. Using the integral representation of the Dirac delta of alpha in terms of e2I alpha x and taking into account that the two integrals give us the same result, we obtain that the integral of cos of alpha x with respect to x from x minus infinity to plus infinity is 2 pi times the delta of alpha. Hence, we find that I of alpha satisfies the differential equation. Derivative of I with respect to alpha equals 2 pi delta of alpha. We have that the solution to this equation is I of alpha equals 2 pi h of alpha plus c, where h of alpha is the Heaviside or step function and c is a constant. The Heaviside function is defined as 0 if alpha is negative and 1 if alpha is positive or 0. In order to determine the constant c, we evaluate I of alpha at alpha equals minus 1. We have that I of minus 1 is 2 pi h of minus 1 plus c. Since h of minus 1 is 0, we get that c is I of minus 1. We can calculate I of minus 1 using the definition of I of alpha. After evaluating I at alpha equals minus 1, we obtain the integral from minus infinity to plus infinity of sine of minus x over x. Using the fact that sine of minus x is minus sine of x, we get that I of minus 1 is minus I of 1. Then we obtain that c equals minus I of 1. Using the expression of I of alpha as 2 pi h of alpha plus c, we get that I of 1 is 2 pi h of 1 minus I of 1. Since h of 1 is 1, we get that I of 1 is pi. Since I of 1 is the integral of sine of x over x from x minus infinity to plus infinity, we finally obtain that the integral of sine of x over x with respect to x from x minus infinity to plus infinity equals pi. The function sine of x is odd, as well as x. Hence, sine of x over x is an even function. The integral from minus infinity to infinity of sine of x over x is 2 times the integral from 0 to infinity of sine of x over x. Therefore, the integral of sine of x over x with respect to x from x equal 0 to infinity is pi on 2. In this video, we have shown a simple way of calculating the integral of sine of x over x with the help of an auxiliary function depending on one parameter. In future videos, we will see how to use this technique to calculate other integrals. If you want to see more videos on calculus and algebra with ingenious ideas, do not forget to subscribe to my channel. Thank you for watching.